Hello friends, today we are going to discuss about inter-process communication. My team members are Shiva Dodda, Manohar Edla, Kishore Sure and myself Venubabu Janalgadda. Let's go into details. Inter-process communication. Inter-process communication is a set of methods for the exchange of data among multiple threads in one or more process. It's nothing but exchange of information among multiple threads. And we are following different techniques in inter-process communication. The techniques are signals, pipes, message passing and shared memory. Let's go into details of signals. A signal is an asynchronous notification sent to a process or to a specific thread within the same process in order to notify it of an event that occurred. It's nothing but informing a process about an event. A signal is generated by the occurrence of a particular event. A signal can be sent from any process to any other process with restrictions on signals sent to process owned by another user. We are having two types of signals, synchronous signals and asynchronous signals. Synchronous signals. These signals are predictable and are mostly generated by hardware. If we consider example, divide by zero, illegal instruction and memory access violation are some of the synchronous signals. Synchronous signals need to be delivered to the thread causing the signal but not to other threads in the process. This is about synchronous signals. Asynchronous signals. These signals are not predictable. These are software generated interrupts. For example, when we want to abort a program using Ctrl C, a signal is generated to break. And one more example we can consider as when we want to change the size of a window of a terminal, a signal SIGWinch is generated. Asynchronous signals should be sent to all threads but not to a particular thread as in case of synchronous signals. Both synchronous and asynchronous signals follows the same pattern of signals. A signal is generated by the occurrence of an event. The signal is delivered to a process and once delivered, the signal must be handled. Let's look into the sources for the signals. We are having few sources which generate signals in operating system. Terminal, window manager, kernel, process. The terminal generates signal when an interrupt happens. For example, if we consider SIGINT is the interrupt generator when we enter Ctrl C and is delivered to all processes or threads associated to the current terminal. SIGUP is hang up on controlling terminal. From the window manager. Window manager is one of the source of signals. When we want to change size of a window or when we want to operate on a window, we generate a signal. For example, SIGWinch, which is used to change the window. From the kernel, usage of time in processes. For example, alarm. Signal is sent to process when the time limit specified in a call to a preceding alarm. From the process, signals provided while killing the process which has been entered into the infinite loop. The signal, for example, is SIGKILL, which is generated when killing the process which entered into the infinite loop. Let's deal with signal handlers. Signal handlers are installed with the signal method. It's a system call, it's a predefined method. If a signal handler is not installed for a particular signal, the default handler is used, otherwise the signal is intercepted and the signal handler is invoked. A signal may be handled by one of the two possible handlers, default signal handler, user defined signal handler. Every signal has a default signal handler that the kernel runs when handling that signal. This default signal handling can be overridden by user defined signal handler. Some signals are ignored, such as changing the size of window, and some signals are handled by terminating the program. Different processes respond to a signal in the different ways. The following are the ways in which a process responds to a signal: ignore the signal, respond to the signal, reconfigure signal, turn on or off option, timer information. Sample code. The following is a sample code to illustrate signal. In this, we used signal function, which is predefined in the main function. The parameters for signal function are signal and method name. Signal is, here we consider sigint, which is an interrupt signal, and method is a function to install as a signal handler. So here the method sample is used as the signal handler. That's about signal handler. Advantage of signal. Signals takes the shortest possible CPU time among the interprocess communication techniques. It is sent on some exception or some condition which can set during running of processor or task or thread. A signal is something like hardware interrupt of software. And one more advantage is, unless the signal is masked, the signal allows the execution of signal handling process. Disadvantages of signals. The main disadvantage of signal is it is handled only by a high priority process. So the process which are having high priority will only handle the process, and the low priority process are unable to handle the signal. And one more disadvantage is signal may be cause re-entrancy problem. These are the few disadvantages of signal. That's about signals, and my friend continue with the next interprocess communication technique. Thank you.
Hi, I am Manohar. I am going to explain message passing. Message passing is an interprocess communication mechanism in which processes communicate by sending and receiving messages. In this, we mainly use two operations. First one is send operation. Send operation is used for sending messages to destination process specified by sender. And the second one is receive operation. Receive operation indicates that a process is ready to receive a message from another process. Next one is approaches to message passing. There are many different approaches to message passing have been proposed. They differ in whether communication is one-way or two-way. The second one, whether the naming of sources and destinations is direct or indirect. And the third one, whether the naming of sources and destinations is symmetrical or asymmetrical. Next one is one-way communication. In one-way communication, a process can only send or receive on a given channel. That means a process can't perform both send and receive operations at a time using one-way communication. But it is possible with two-way communication, and we need to establish two channels for two-way communication. Generally, all the message passing primitives use one-way communication. That's the end of one-way communication. And now, second approach to message passing is based on naming sources and destinations. The naming of the sources and destination can be either direct, indirect, symmetrical, and asymmetrical. First one is direct naming. In direct naming, we give unique names to processes, and based on that unique names, communication is done. In indirect naming, processes use names of channels or mailboxes for communication. Next one is symmetrical naming. There are two variations in symmetrical naming. First one, in symmetrical direct naming, both sender and receiver name the corresponding process. Whereas in symmetrical indirect naming, both sender and receiver name the corresponding channel. Similarly, in asymmetrical direct naming, the receiver can receive the message from any process. And in asymmetrical indirect naming, the receiver can receive messages from any channel. That's the end of approaches to message passing. And now there are mainly two types of message passing. First one is synchronous message passing, and the second one is asynchronous message passing. Synchronous message passing. If the sending process is delayed or blocked until the corresponding receive is executed, then that type of message passing is called synchronous message passing. Coming to the properties of synchronous message passing, first one is both the send and receive operations are blocking. That means if a process executes a send operation, it will be blocked until it executes the corresponding receive operation. The second one is a process sending message to a channel is delayed or blocked until another process is ready to receive from the channel. And the third one is there is no need of buffering. That means no need to store messages temporarily. There is one drawback with this synchronous message passing. That is, whenever two processes communicate, at least one of them will have to block. So it can result in reduced concurrency. The second type is asynchronous message passing. If a process sends a message and continues executing without waiting for the message to be received, then that type of message passing is called asynchronous message passing. The properties are: first one, send operations are non-blocking. The second one, sender can get far ahead of the receiver. Third one, message delivery is not guaranteed if failures can occur. And the fourth one, since channels can contain an unbounded number of messages, there is a need for buffering. There are some drawbacks with this message passing also. First one, the receiver can't know anything about the current state of the sender. The second one, the sender never knows if the message was reached or not until the receiver sends a reply. And the third one, it is hard to detect when failures have occurred. There are some advantages and drawbacks with message passing. Advantages include the hardware can be simpler. Second one, communication is explicit and simple to understand. In shared memory, it can be hard to know when communication is going on and when it's not. Third one, we can achieve synchronization with sending messages, reducing the possibility for errors introduced by incorrect synchronization. And the fourth one, easy to use sender initiated communication, which may have some advantages in performance. There are some drawbacks with message passing also. First one, data inconsistency problem arises because messages can be out of order. That means the sequence of messages is not consistent. Second one, messages can be incomplete because receiver has not enough buffer space. Third one, messages can be lost. And the fourth one, messages can be outdated. That means they no longer reflect the current state of the sender. The second drawback is each message can be an information leak. So there must be some control whether messages should be transferred or not. To explain message passing mechanism, let us consider the famous producer-consumer problem. In this example, a buffer size of 4 has been chosen. First of all, the consumer begins the process by sending 4 empty messages to the producer. The producer creates a new item for each empty message it receives and sends the item along with message to the receiver. After that, it goes to sleep. The producer will not create a new item until it first receives an empty message. The consumer waits for messages from the producer which contains the items. Once it consumes an item, it sends an empty message to the producer. This process goes on. We can achieve synchronization in this example because when the producer is producing an item, consumer won't do anything except waiting for message containing item. When the consumer is consuming an item, producer waits for empty message from the receiver. Thus, synchronization is achieved with message passing. This is the end of message passing mechanism concept.
Hi, I'm Kishore Suri. I'm here to present the topic shared memory. Shared memory is an efficient means of communicating between the processes. It can be easily processed to communicate by reading and writing to specified memory location. Here the figure shows the shared memory segment where the processes 1 to n communicate by using the memory segment. Shared memory is one of the simplest and fastest form of inter-process communication because all processes share the same piece of memory. It avoids copying data unnecessarily. One of the major drawbacks using the shared memory is race conditions. The problem can be avoided by one of the strategy is to use semaphores. In general, one process creates or allocates the shared memory segment. Next, moving on to creating a shared memory segment. Process to create a shared memory segment by using SHM get shared memory get. There are three arguments in creating the memory. First argument indicates creating a segment is IPC create. This permits creating a new segment while specifying the key value. The second argument, which is always used with IPC create, causes SHM get to fail if a segment key is specified that already exists is IPC EXCL. The last argument for SHM get, SHM flag, is used to indicate SHM get creation conditions. Example, IPC create, IPC exclusive, and access permissions. Next, moving on to shared memory operations. There are two shared memory operation system calls. The first, SHM-AT, is used to attach the reference shared memory segment into the calling process data segment. There are three arguments. The first argument to SHM-AT, SHM-ID, is a valid shared memory identifier. The second argument, SHM-ADDR, allows the calling process some flexibility in assigning the location of shared memory segment. The third argument is a flag, which include SHM RND, indicates that the address specified for the second parameter. SHM RD only, read only, indicates the segment will only be read, not written. The second shared memory operation is SHM-DT. Shared memory detach is used to detach the calling process data segment from the shared memory segment. Next, moving on to controlling and deallocating shared memory. The SHM-CTL system call returns information about a shared memory segment and can modify it. There are three arguments for the SHM-CTL system call. The first, SHM-ID, is a valid shared memory segment identifier generated by prior SHM-GET system call. To obtain information about a shared memory segment, pass IPC_stat as a second argument. To remove a segment, pass IPC_RMID as a second argument and pass null as a third argument. Shared memory should be explicitly deallocated using SHM-CTRL. Let us consider an example which explains the system calls used in the shared memory. Here in the program, first, we use the command SHM-GET system call creates a shared memory and returns an integer which is assigned to segment ID of type integer. Next, the command SHM-AT attaches shared memory specified by segment ID to shared memory. Here we are using SHM-CTL to determine the segment size. To detach the shared memory segment, we use SHM-DT system call. And finally, to deallocate the shared memory segment, we use SHM-CTL system call along with the required arguments. There are some advantages and disadvantages of shared memory. The basic advantage of shared memory model is that the programming for inter-process communication becomes simple in the sense that we simply write and read to an address pointer available in our process address space. We need not use system calls like write and read. Advantages of shared memory. The disadvantages of shared memory for computer graphics include slow speeds and reduced availability of resources. This is used by on-the-board video call in many computers as a way of lowering costs.
Hi, I am Shiva. Here I am explaining the pipes concept. Pipes is one of the important technique we are using in inter-process communication. It is the communication interface between two processes where it connects the standard output of one process to standard input of another process. Here is the example. Here the output of ls command as input of sort and output of sort as input of lp command. There are two types of pipes, ordinary pipes and named pipes. Coming to ordinary pipes, it provides unidirectional communication between processes. It allows one-way communication only. If we require two-way communication, we should use two pipes. It is called as anonymous pipes on Windows. On Unix systems, ordinary pipes are constructed using the following function: pipe of array file descriptors. Here we are using two file descriptors. One descriptor is used to write the input file into the pipe, and another is used to read the data from pipe. Parent-child process is required. Here parent process creates a child process, and in this ordinary pipes, parent process writes the data to the pipe and child process reads the data from the pipe. Here one thing to notice that is both the parent and child process closed their unused ends of the pipe. Let us look into the sample code. Here I am just explaining the function of the pipes, means how to create the pipe and how to create the child process like. Here I am using standard library functions. Here I am creating the buffer size of 25, read and write, and I want to write this message greetings. In this inter-process communication, the process sends the message from one process to another process through the pipe. So we need to create the pipe. This is the function we are using to create the pipe, and we are calling the fork call to create the child process. If process ID less than 0, fork is failed, means child process not created. If process ID greater than 0, it is the parent process. Parent process closes the unused end of the pipe. Write. The parent process writes the data to the pipe and then it closes the right end of the pipe. Else. Here else means process ID equal to 0, means child process is created. It closes the right end, means unused end of the pipe, and it reads from the pipe, and then it closes the read end of the pipe. Coming to named pipes, it provides bidirectional communication between processes. Named pipes continue to exist after communication process have finished also, and it will exist until deleted from the system. These are referred as first in first outs on Unix systems. The first in first out is created with make first in first out system call and manipulated with the ordinary open, read, write and close system calls. Although it is bidirectional, half duplex communication is allowed. In this, the communication process may reside on same machine. Full duplex communication is also allowed. In this, the communication process may reside same or different machines. Coming to the advantage of pipes. Pipes can solve the synchronization problem of files with blocking read and write. Here the message is sending from one process to another process. The message sent from one process, then it closes the right end, and when the another process reads that message, it closes the read end after reading. So we don't have the synchronization problem between the two processes here. The small size of pipes means that pipe data are seldom written to disk. They usually are kept in memory. Pipes can be used where only pipes can be used. Pipes can be used across different systems. Coming to disadvantages of pipes. File descriptor for pipe is private to process that created it and it designates. Reader and writer must be related. The example for this is parent and child process, and the pipes parent and child process is related here. Pipes can be slow if there is lot of data to copy via buffer. The huge data may slow the pipes. These are the 4 techniques we are used in inter-process communication. Thanks for watching.